Everybody to our new podcast with the doctors Dr. Denny Hatka and Dr. Anmol Paudel and myself Chaitanya Darshan.
Hello.
So we will discuss today. We'll discuss about antimicrobial, basically antimicrobial cell wall synthesis inhibitor and protein synthesis inhibitors, and we'll talk few things about this sedal and static things, and we'll talk about some resistance phenomena. So I would like to start. So from Dr. Khadka, so can you just give me the introduction about the antimicrobial resistance? How the antimicrobial resistance basically occur? Simplified the
Yes.
mechanism way.
Okay.
Can you give us some examples like any of the antimicrobial?
Thank you, Chaitanya. I will try to exemplify some antimicrobials.
Yeah.
The resistance means there is no effect of
Drug.
on
Yeah.
the respective microorganism.
Yeah.
There are various mechanisms. One of the famous is bacteria acquire some kind of efflux mechanism.
Yeah.
Whenever the drug is uh, inside their cell wall or a membrane, and they will efflux that drug. And other very famous is phase related.
Phase. Yeah.
Phase related.
Yeah.
Phase related resistance is very important, as well as there is some kind of chromosome related also.
Yeah.
And some kind of neutralizing enzyme also there. No?
Yeah. Yeah.
Penicillase is
Yeah.
one of the
Enzyme.
enzyme.
Yeah. So, thank you, Khodka. So, Dr. Paudel, so can you? I want to introduce one simple definition of phenomena. Like a total microbial population was found to be susceptible on testing. Some in a population, if microbial, some of the population is microbial susceptible, and in same population for same drug, some of the population is resistant for that drug. That phenomena is called as the heteroresistance. This is a unique term, so just I introduced the term heteroresistance.
Okay.
So, Dr. Paudel, so can you just give me how the penicillin resistance mechanism for the penicillin resistance? Can you briefly explain the mechanism for the penicillin resistance?
Okay.
Yeah.
First of all, you already told about the mechanism of resistance of the organism through various mechanisms to the drugs.
Yeah.
Is it any added alteration of penicillin binding protein is the main. You are talking about beta lactams.
Yeah. Yeah.
Beta lactams resistance is mainly due to production of beta lactamase.
Yeah.
Actually, beta lactam antibiotic contains beta lactam ring.
Yeah.
That ring is main mechanism. That ring also determines the mechanism of action of that drug,
Yeah.
beta lactam drugs.
Yeah.
But there are some organisms that produces the enzyme beta lactamase.
Yeah.
Like penicillinase is also a type of beta lactamase. Okay.
Yeah.
So what happens is they destroy the beta lactam ring.
Yeah. Yeah.
Once the beta lactam ring is destroyed, the cell wall by the drug cannot be destroyed of the organism.
Yeah.
I mean to say, the drug cannot destroy the organism if the beta lactam ring of the drug is destroyed.
Yeah.
This leads to resistance of the beta lactam antibiotic like penicillin.
Thank you.
Is there something more than this?
I would like to add a few things.
Yeah. Yeah.
In penicillin, this make a
gene.
That was a beta lactamase gene. Beta lactamase.
The gene that codes the beta lactamase enzyme. Is that?
Yes.
That neutralizes the beta lactam ring, so resistance may be occur because of the make a gene, you want to say.
Yes.
Yeah. Yeah. So just Dr. Paudel and Dr. Khadka mentioned about the resistant, but by the on the basis of this bacterial genetics, if you say pneumococcal resistance to penicillin G, the mainly acquired by the mechanism called as a transformation.
Yeah, all those four actually what happens is four stages are there that organism undergoes,
Yeah.
and that organism becomes resistant to drugs.
Yeah.
They are transformation, conjugation, transduction, and transformation.
Yeah.
Okay.
Yeah.
For example, I would like to add MRSA
Yeah.
is due to transformation of the mechanism of the
Yeah,
bacteria.
Marius. Yeah, okay.
Okay.
So other resistance, like if you talk about the, I just mentioned like single pneumococcal resistance, but if you talk about like multi-drug resistance, if you talk about the multi-drug resistance, that is actually transferred through the conjugation mechanism of the conjugation. If you talk about the multi-drug resistance, if you talk a single drug like penicillin G, and it is because of the transformation. This is basically bacterial genetics.
Sorry, will you repeat it again?
So means if you say like one single drug like pneumococcal resistance for the penicillin,
Yes, this is single event.
yeah, event that is basically by the mechanism of transformation. And if you talk about the multi-drug resistance, we have like TB medicine, multi-drug resistance in TB. Yeah, it is because of the conjugation mechanism called as the conjugation. So let's talk about the bacteriostatic and bactericidal phenomena. So Dr. Khadka, what do you understand by the meaning bacteriostatic and bactericidal? Can you just simplify the term so that we can learn easily?
Static means static form. There is no increase in quantity.
Yeah.
But the organism is not totally eliminated.
So means
That
in a control way.
In a control. That is that in every growth there is like exponential growth originally
Yeah.
in the organisms, but that in a simplified version the growth is exponential growth is somewhere hindered, but the organism are totally not eliminated. Okay?
Yeah, you mean to say
Lag phase is there is
Yeah.
some called lag phase.
lag phase. Yeah, means you want to say like if a bacteriostatic drug basically it will control the multiplication of the bacteria.
Yes.
Is that so? How the mechanism for the this bacteriostatic drug? What is the mechanism? Dr. Powder?
Very hard to say. What
Say mechanism is just mentioned like bacteriostatic means the control way of the this multiplication of the bacteria. So what is the mechanism behind for this control of the multiplication?
What
of
is the mechanism of bacteria for making it not entering into the log phase?
Yeah,
You mean to say?
yeah, yeah.
That is
metabolite, maybe metabolite is hampered.
Yes, yes. You mean metabolite means we have to stop their protein synthesis. Is that?
Yeah.
Protein synthesis is basically those drugs that inhibit the protein synthesis. These are the bacteriostatic.
I recall it.
Yeah.
Pseudal is destroying the cell wall. Starting mean stopping the protein.
Yeah.
Yeah.
Once a bacteria cannot synthesize its protein, it cannot make another bacteria.
In very genetic term, there is very fancy term for this. One is constitutional genes,
Yeah.
and one is some reproductive kind of genes. One constitutional means for homing, for surviving, for nutrition. This kind of gene set are different.
Yeah, constitutional.
And for reproduction, that is different.
Yeah.
So two sets of
Gene,
genes in very basic organism also have this set of
Gene.
constitutional genes
Yeah.
and reproductive genes.
Gene,
That's why they are controlling in constitution.
Are all bacteria that
Inhibit the protein synthesis and the bactericidal?
bactericidal?
No. So just I am going to for that topic.
not always like that.
Yeah. So let's conclude what are the drugs under the protein synthesis inhibitor means bacteriostatic drugs. Can you just give me example, Dr. Khadka? Bacteriostatic. Yeah.
there are also drugs which inhibit protein synthesis and are pseudal.
Yeah. Let's first collect the number of the drugs that are that inhibits the protein synthesis and bacteriostatics. Start from Dr. Khadka. Can you just enumerate? Yeah. Yeah, linezolide. You can linezolide one of the example. Other is if you sulfonamides, erythromycin, and tetracycline, clindamycin, chloramphenicol. You just said, and ethambutol. and one another is the tegacillin.
These are, you are talking
These
about all protein synthesis drugs.
protein synthesis inhibitors.
Not 30 and 50, but
Yeah.
just holistic example.
Yeah.
Also you had streptogramins, okay?
Yes, yes. So let's talk about the now. Let's try to enumerate the some sedal drugs. Can you, Dr. Paudel?
Pseudo mean that restore the cell wall.
Yeah.
I'll start from the penicillin group of drug.
Yeah.
Then I'll go to other cell wall inhibitors like bacitracin.
Yeah.
Okay. Polymyxin.
Yeah.
Flucide anti-pseudomonal drug like piperacillin, ticlacin. These are also same thing.
Yeah.
Cephalosporin also cell wall.
Yeah.
Vancomycin also again cell wall.
Yeah.
Okay.
Yeah.
Other what you want?
Yeah. Yeah. I want to add more.
Daptomycin also.
Yeah. Daptomycin and
Metronidazole is
metronidazole and isoniazid also.
Actually, metronidazole is not cell wall synthesis inhibitor.
No, means it's in a total way. It basically it inhibit by this free radical mechanism.
No, DNA synthesis inhibition. It generates free radical that destroy the bacterial DNA.
Yeah, but
This is not the.
but it is under the sedal group. Maybe
Yeah.
it doesn't inhibit the cell wall synthesis. You just mentioned.
Just I want to just correct you that you
Yeah.
have written is under cell wall inhibitor. This is not cell wall inhibitor.
Yeah.
This is the DNA. It destroy the bacterial DNA
Yeah.
by free radicals. Okay?
This is also Thank you, doctor.
Quinolone is left. No?
Yeah.
What is the class of quinolone? Where
It's a fluoroquinolones means it is under the bactericidal.
sedal?
Biggest cell wall inhibitors. So let's talk more about the protein synthesis inhibitor. On the protein synthesis inhibitor. So I want to start from the Dr. Paudel. So Dr. Paudel, so can you say tell me about like drug of choice for treatment of tularemia in tularemia.
Sorry.
Tularemia is a disease condition. What is the drug of choice that is used in the tularemia?
Tularemia is, I would like to say first of all, this is caused by gram-negative organism.
Yeah.
So cover the gram-negative organism, go with aminoglycoside like gentamicin, amikacin.
Yeah.
If it doesn't work, go with streptogramins, which are the last resort that inhibits.
I think it is sulfonamide. No?
No, it's streptomycin is just mentioned and or gentamicin. Streptomycin same under gentamicin streptomycin. So inhalational formulation of which of the following aminoglycoside is approved for the use of the cystic fibrosis? Dr. Khodka, this is very interesting fact one. If you remember, just can you give me the name of the inhalational formulation?
Actually, he is asking the inhalation. No, it is tobramycin.
Yeah, tobramycin for the
Actually, I like to something add to it. Cystic fibrosis main you should cover the organism is Pseudomonas.
Yeah.
Then Buctophilia. Okay.
Yeah.
First common is Pseudomonas.
Yeah.
Second common is Buctophilia.
Yeah.
So to kill Pseudomonas you have lots of drugs.
Yeah.
But in inhalation form, as you told, that is only
Tobramycin.
But other drug that kills the Pseudomonas are, let us talk that. What are the drugs that kills the Pseudomonas?
Pseudomonas, you can some bacterial sedal drugs.
What are they?
You can use ciprofloxacin. You can use
Septomycin, carbapenems, okay, camphire. Could you repeat the name of camphire?
this camphire is the chloramphenicol.
Yeah.
A for aminoglycoside.
C is not for chloramphenicol, mind it. C is for carbapenems.
Yeah.
A for aminoglycosides.
Yeah.
M for
Macrolides.
no monobactams.
Monobactam.
Okay. P for this
Penicillin.
was last time INICET or PGI question.
Yeah.
Polymyxin is the last resort for cholesterol and polymyxin last resort for Pseudomonas. Okay.
Yeah.
Then fluoroquinone like ciprofloxacin, you told this thing, no?
Yeah.
Fluoroquinone.
Yeah.
Third generation, what are the cephalosporin that used for Pseudomonas? You also know that.
It's fourth and fifth generation cephalosporin.
Cephalosporin, okay.
Yeah.
That are the drugs that cause.
So the absorption of the aminoglycoside from intramuscular site is rapid peak concentration seen with the following range. Like in 30 to 90 minutes, the peak concentration is achieved by the intramuscular injection of the aminoglycoside. This is basically fact related with these aminoglycosides. Yeah. Aminoglycoside clearance is reduced in the renal failure. That's also
Why? What is happening?
Yeah.
Why?
Mechanism wise, it is basically nephrotoxic. So I think Because it is metabolized through the renal mechanism. So
First, tell me mechanism of clearance of drug. There are two mechanisms.
Clearance.
Phase 1 and phase 2. Okay.
Yeah.
What comes under phase 1?
Phase 1 is the oxidation and reduction.
ROS.
Yeah.
Reduction, oxidation, and
Hydrolysis. And phase second is the methylation, glucuronidation, and acetylation and sulfation. Yeah.
Under which group does aminoglycoside come there?
Which phase you mean?
Yeah, under which phase is false?
It's I'm not sure, doctor.
You know any?
Yeah.
Then maybe
Dr. Khodka, do you know?
Glucuronation, I would go with two renal excretion.
Renal excretion, is that by the phase 1 or phase 2? Most of the drug by the phase 2, so I think I would go with the phase 2 also. Is that right?
Yeah, these are not cytochrome P40, no?
Yeah.
Those drugs which are not metabolized by cytochrome P40 are phase 2.
Yeah.
Phase 1 is only cytochrome P40.
Yeah.
So all inhibitor and inducer are metabolized by phase 1. The rest all drugs are metabolized phase 2. Make it simple.
Yeah.
Okay.
So it's by phase 2 you mean to say. So let's talk about the mechanism mainly responsible for gentamicin induced ototoxicity. Dr. Khodka, what is the mechanism for the gentamicin ototoxicity, gentamicin induced ototoxicity? Where does it what does it do with our ear cells?
This is one of the very
We did the PhD in
famous
this, no?
concept.
Yeah.
Outer ear cells.
Famous
Destruction of outer ear cells.
Yeah, it's basically directly to the hair cells.
Direct toxicity.
Direct toxicity to the hair cells. So vestibular toxicity is predominantly seen in the streptomycin among this aminoglycosides. So aminoglycosides having less effect on neuromuscular blockades. Can you give me tobramycin? Yeah. So decrease in the potency of the neuromuscular blockade by the
acetylcholine अथवा
can you give me the by highest one among the aminoglycosides?
who has the highest
Highest decrease in the potency of neuromuscular blockade if you give aminoglycosides neuromuscular blockade parallelly.
neomycin.
Yes, exactly, you're right. It's neomycin one higher.
It comes under anesthesia also, no?
Yes. So on by neomycin on decreasing order like kanamycin, amikacin, gentamicin and tobramycin.
Least is Tobra.
Yeah,
Maximum
high
is
neomycin.
Neo.
So organism resistance to tetracycline. What is the organism responsible for tetracycline, Dr. Paudel?
Sorry?
What is the organism that is resistant to the drug tetracyclines?
Oh, very nice concept. What is he going to ask?
Tetracycline means it inhibits 30 years.
Yeah.
Okay.
Yeah.
30 years means
We just talk about pseudomonas covering
Pseudomonas
drug.
it does
So
not cover.
it's pseudomonas. It is resistance to the pseudomonas. So minocycline derivatives that is active against the instance resistance to the mainly tetracycline is a tegacyclines. This is a fact actually. Minocycline derivatives that is active against the instance resistance to the mainly for tetracycline. Among the tetracycline, if you talk about this minocycline derivatives, there is a one drug called as tegacycline, which is active against that resistance mainly for the pseudomonas is called as the tegacycline.
Okay. It is actually tetracycline is container, tetracycline container. It's okay. There is
It's
one
derivatives of the minocycline.
One new
tegacycline.
thing I have written in meningococcal carrier.
Yeah.
We have been talking about rifampicin and
But there are
ciprofloxacin. Minocycline happens to be the one drug.
It is actually it depends upon the age wise. It's a different according to age. I'm not.
actually tetracycline was discovered for those organisms which are not covered by tetracycline. It's a new drug.
Yeah. So doxycycline can be the doxycycline uses. I want to mention more about the doxycycline uses. Like it can use in the leptospirosis and lymphogranular venorum and this borreliosis. So
Is there a class of tetracycline? Like in first class there happens to be oxytetracycline. In second class
Yeah.
Demoxycycline, in third class
It is
doxycycline.
given
Yeah.
in some pharma.
Yeah, it is given actually. I don't remember what I just mentioned thing. The tetracycline, which is the derivative of minocycline.
Now
Which
you
is,
tell me,
yeah.
what is the difference between tetracycline, a mechanism action of tetracycline
And
and tricycline that is making better
for the
use
coverage.
for the use.
Yeah.
Why we are using tricycline nowadays in many ICU they
Yeah.
use tricycline. Okay.
Yeah.
What is that special feature of tricycline that is more smarter than tetracycline?
Can you? I don't know, Doctor.
Tetracycline?
Yeah.
Yeah.
Can you just elaborate, Doctor Khodka? You are smarter in this mechanism, no molecular things. You like that? I think.
I had to, but I had some kind of difficulty recalling it right now. I had flashcard regarding tetracycline.
The
but
main
it's somewhere
thing is
there.
simple, very simple.
Yeah. Yeah.
Tetracycline is renal toxic.
Yeah.
Tricycline is renal safe.
Oh.
This makes the drug better to use than
Yeah. Oh.
Tetracycline. We are
Yeah.
talking about
Tetracycline is more safe in the renal.
you can use tricycline in renal failure patient, but you cannot use tetracycline in
In the
renal.
renal fan.
So you are saving your kidney. So you are making your nephrologist more happy.
Oh,
So that's the way to
concept arises from making a tetracycline
More
with
safe.
pseudomonal sensitive.
yeah.
With the renal safety.
With renal safety.
Yeah.
They will do that.
So let's talk more about the.
Use of doxy a little bit more.
Yeah. Let's thank you, doctor. So let's stop about our discussion about this antimicrobial and on basically on the protein synthesis. On our next podcast we'll talk about more about antimicrobial resistance. Thank you everyone.